time for another video. This one is on environmental hazards and human health. Chapter 17 from the textbook. Alright, so a good starting point is to talk about the AIDS epidemic. And this was a global situation, and this I do remember when it first cropped up in the 80s. And here in the United States, it was a death sentence for people who got the HIV virus and AIDS from there. Now, the idea there is that your immune system is compromised, and before you know it, your body can't fight off anything. And like I said, usually a death sentence for the people who would get it. And then, not too long after that, we figured it out, where you can actually live, and there's treatment that you can have, and medicines that you can have. And this was more prevalent in the developed world than it is in the developing world, where they still have a big problem with the idea of the AIDS epidemic, and that has affected their countries big time. Okay, so this is just a disgusting skin disease that you're more susceptible to. With AIDS, and that was a lot of what would happen. The physical signs of it were terrible, and then the death that followed. So in large parts of the world, that is still the case. This is an African country. I'm not sure, I think this is Nigeria, but this is a country where you could see the age structure and how the age structure changed. Botswana, this is Botswana, and you can see how the age structure changed with and without AIDS. So a very dramatic difference there. The life expectancies in that part of the world dropped dramatically because of the AIDS epidemic, and still are bouncing back. There had been improvements, and it really took a hit. Okay, so when talking about things, we'll talk about the risks that we have involved, and with that the idea is risk assessment and risk management. Sometimes maybe we don't really understand what the risks are. Sometimes we maybe think that things are more dangerous to us than they're going to be, like shark attacks maybe. And then sometimes we think about maybe things as not being dangerous enough to us. Maybe cigarette smoking for some people, because the effects aren't immediate. And risk management is what you do to cut down on the risks or to live the way you want to live, and that's the idea of the risk management. You know, there really is not a very big chance of dying from a shark attack, but you can certainly manage that risk by never going in the ocean. That cuts it down to zero, unless there's a sharknado. Then you can have to worry about that. Okay, so this is the idea. What is it? How likely will it be to happen? And then the risk management is, what can I really do about it? And if it's large-scale chemicals or something like that, we're going to have to also ask about how much money is going to be involved in that, and what the value of that is. Okay, so we face 5 types of hazards here, and we're going to talk about all of them here. When they are biological, they're called pathogens. We also have chemicals that we've created that cause problems for us. We'll discuss those. Physical things that can hurt us, of course, things that because of our culture can affect us, and then how we live our lives as well. And sometimes how we live our lives and what our culture is has something to do with that as well. Alright, so first we'll talk about the biological hazards, and at the making of this video I am recovering from the flu. So that's one of the most serious infectious diseases, and I'm certainly happy that I live in a part of the world where this is not a death sentence for me, but for many it is. Okay, so we'll break down these things here. One thing is diseases can be non-transmissible. Heart disease is non-transmissible. Cancer is non-transmissible. Infectious diseases are diseases that are caused from infections. And transmissible diseases can be transferred from one group to another, one person to another, or an animal to a person as well. Okay, we have cut down on in the United States because of better health care, antibiotics, and vaccines. We have cut down dramatically on the diseases that we have to face. But in other parts of the world, that's not quite the case. The pros on this are people get to live a little longer. As I am now getting a little bit older, I appreciate that idea of people getting to live a little bit longer. I'd like to hang around for a while. That's a pro. Better lifestyles, that's good. We're healthier throughout our lives because of these things in general. In cons, there's more people, so we have to take care of more people, and that's resources as well. Again, being a little older myself, I see it as a pro that people are living longer. But the antibiotics are also an issue too, and that is that as we are creating better antibiotics, the bacteria that is resistant to the antibiotics is what survives. And so it becomes this arms race, and the bacteria becomes stronger and stronger and harder to kill with the antibiotics that we know of. We have to keep coming up with new ones. And that's a little bit daunting task there, and hard to do. Pesticides as well, and we cut down on the amount of diseases because of killing insects. But then we get insects that are resistant to the pesticides as well, and the insects and the bacteria spread so rapidly and multiply so quickly that they are naturally selected. These resistant pests and these resistance bacteria, and they can cause more problems. Okay, cardiovascular disease is ahead in the United States. You would think maybe we'd be ahead of the world on that one. Well, we are. We have more cardiovascular disease than the rest of the world does. Can you think of the reasons for these things? It's always good to kind of think of the reasons behind it. And if you're confronted with a fact, good to think about maybe where that came from and what it could mean. But with the cardiovascular disease in the United States, part of the reason is we have accessible to us lots of food, so we eat more, and also the cheapest food is low quality food. We have a lot of that available to us, so that leads to cardiovascular disease, as well as sedentary lifestyles. We don't move around as much as we used to, or as maybe people do in other parts of the world, and that cuts down on, increases the amount of strain on our hearts. Infectious diseases in the world, we're way behind the rest of the world, and that's due to the antibiotics and the vaccines and better sanitary conditions. How about cancers, though? We're ahead than the rest of the world in cancers. Any theories on that? Well, I have a couple theories. One is that maybe we're living longer in the United States, so cancers that maybe didn't affect people until later in their life could be a possibility. Another possibility is that with all of our technology, we're exposing ourselves to carcinogens, cancer-causing agents, more than the rest of the world is. So these are possibilities here for why the United States is ahead of the rest of the world in cancer. Okay, where is this disease coming from? So you can't avoid it. Bodily fluids is a big one. They're coming from the food, our water, and from our air. And I've already talked about the resistance of bacteria and insects as we use new antibiotics, and that becomes a problem. Epidemics are things that happen locally, where there's like now a flu epidemic going on. I got caught up in the flu epidemic this year. And pandemics are global, so the AIDS pandemic, I guess you would have to say. Okay, so here are all the ways the world is trying to get you. So this is the way diseases can come to you. And of course, once you have them, you're also able to transmit them to other people as well with these biological pathogens. So yeah, nothing is really safe, I guess, is what it comes down to, or completely safe. Okay, so here we go. The flu, as I said, I have it right now. I'm just coming out of it. But 3.2 million people. These numbers are from a few years ago, but it gives you an idea of the trend that is still going on here. These infectious diseases, biological diseases. So tuberculosis, very interesting to study the idea of tuberculosis. Happened in the early part of the 1900s in the United States here, and worldwide it's still going on other places. You can see we've eradicated it here once we understood it, but it took a while to understand it, and that's a fascinating story. It was originally called consumption. And just a very interesting story of the history of tuberculosis. And now that we really don't think about it hardly at all. Okay, so I've already talked about the use of antibiotics and pesticides and the problems with them. Natural selection, and this spreads the genetic resistance quickly and easily. And here's an example, a modern day example. This is a resistant strain that has been developed because of genetic resistance to the antibiotics. And a lot of times in hospitals this becomes a problem, that it spreads around. And so this is one that we have to look at, and we constantly have to look out for the newest thing as the game changes continually. All right, so tuberculosis, like I said, do yourself a favor if you want an interesting story on how diseases are determined, how they're figured out, and eradicated in some cases, and what the controls we can have on them. But throughout the world, it's something that doesn't happen as much as it happens in the United States. And there's more person-to-person contact, and of course, folks with AIDS are more susceptible to anything anymore. So that's another one. Here it is again, my flu. I'm glad it's not a killer for me, but I certainly have pretty great medical care here in the United States to help me through it, and And I was able to take off a bunch of days from work too, which means that I was not transmitting it to you, so you are welcome. Okay, so HIV is a big killer, can be treated now with drugs. So it is not a death sentence if you have the money for it. So this is what we've done. We've educated people, supplied drugs at low cost, and really tried to cut down on the HIV, and it has largely been successful. Hepatitis B is also spread in a similar way as HIV through bloodborne pathogens, people sharing hypodermic needles. Is a possibility, even blood transfusions before we knew what was going on, and also through sexual bodily fluids being transferred. This is a way that hepatitis and HIV have been spread. West Nile virus and SARS come from animals. There's a little remnant of my flu right there. So animals to humans is a possibility. Lyme's disease through ticks is a good example. Malaria through mosquitoes is a good example. So yes, cut down on your chance of infection. Wash your hands regularly. I always do that, and I still got the flu. Don't eat in the science classroom, or any other classroom for that matter either. There's a lot of crazy germs there. So around the school you can prevent things too. Because there's lots of people. That means lots of germs, lots of potential. Ecological medicine is fascinating. This is about diseases that are spread from animals to humans, and there are people out there constantly trying to get ahead of the next big outbreak that's possible. And where they go is where there's new development, because as we go into new areas and we're clearing areas out, we're more exposed to these animals and more exposed to these diseases too. So here are a few of them that we have discussed already. And the Lyme's disease is a big one here in New Jersey, and you may know people who have been affected by that. That's another one, too, where you never get rid of it, but there now are treatments that can give you a better quality of life than in the not-too-distant past. That one wasn't too long ago that we were figuring that out. All right, and malaria, as I mentioned already, and malaria is, mosquito is the vector. The vector is the way the disease comes to you, and mosquito is the vector for that one. And that's a pretty serious one there too. So there are things that we can do, but of course it's a mosquito problem. So as we have insecticides that are ruling out the mosquitoes, and there's more mosquitoes that are resistant to that, that becomes a problem. Mosquitoes are they favor warm, wet climates, and because of that, as the climate gets warmer, this becomes a problem. In the United States, we don't really have a malaria problem anymore, but we once did, and as you can imagine, it was in the South, where the temperatures are warmer for longer, and there's a lot of moist areas. And actually the CDC, the United States Center for Disease Control, is in Atlanta, and that's where it was originally formed because of getting rid of malaria. And Atlanta was where it started and where it stayed, the CDC. All right, so there are things that we can do right now. And, these are places in malaria where there are, in the world where there are current cases of malaria that are prevalent. You can see the warmer areas. India is a big area, and I had a student from India who had contacted malaria 3 different times in his life, and very interesting to hear his take on that. And he said that, you know, he was fortunate because his family had enough money that he could get the proper treatments 3 times with success. And he said that if you don't have the money, it can be a death sentence or a very different life for you if you don't have the money for that treatment and you happen to get malaria. So there's things you can do, of course, insecticides, cover yourself, anything you can do to keep the mosquitoes off you. So the right kind of clothing, and when you're in these areas, it's so hot, so kind of hard to cover yourself head to toe all the time. So a mosquito net is a good idea there too. Just keep those mosquitoes off you. All right, so these infectious diseases, there are more vaccinations out there. Another thing with these diseases too is a lot of times you need to rehydrate. I got very dehydrated with this flu, but I have good water around all the time that I can be drinking. In other parts of the world they don't. And this is something that the Gates Foundation is very involved with in the developing world with rehydration kits. If your water is of bad quality and that's what you really need, well, you're in big trouble. But these rehydration kits are relatively inexpensive and helped a lot of people. But on the other end of it, there's still a lot more money needed for these things if you think that wiping out diseases and that quality of life for people is important. Okay, so this is a good place to pause if you want. I'll give you a little time to pause and maybe take a look at these. We've basically talked about all of these things. Maybe toward the end there, talking about how diarrhea is a big problem. And when you have that, it's very unpleasant, as you know, and you need to be rehydrated. So down toward the end of the list, that's a good one there, the oral rehydration kits, a reminder of that one. Okay, so I'll pause and give you time to take a look at that. Okay, back from our infectious diseases and moving on here. So here are some of the things that chemicals can cause problems for. Toxic chemicals are things that cause us discomfort or death. Carcinogens will give you cancer. Mutagens will change the DNA, so it changes your genetic structure. And teratogens are birth defect causing. Okay, so I'm going to mention this to you now. Here are PCBs. So if we're talking about some of these chemicals that get into the environment, PCBs are a good case study to talk about. Polychlorinated biphenyls, and these are basically plastics that have gotten into everything. And they're in the environment, they're in you right now, they're in your soil, they're in your water, and they are just so prevalent. They do not break down. So they are fat soluble, and as we mentioned before, that means they will accumulate over the lifetime of an individual. So you can't get them out of your system once they're in there, and biomagnification is as they go up the food chain, because every little bit that your food source has taken in, you now take in if you are higher up on the food chain, and that amounts to a lot higher dosage for you, biomagnification up the food chain. So yeah, these chlorinated carbons, or fluorinated carbons, compounds I should say, are very difficult to get out of the environment. So these have been banned, but they're found everywhere. Here's a little diagram here. These are the biphenyl rings, or the phenyl rings so there's two of them. These are carbon and hydrogen rings, where we have now attached chlorine to them, and that's the problem, the chlorine or the fluorine. Very hard to break down. Okay, and this is just an idea here of how it gets into everything, how these things get into everything. So maybe good to take a little pause, and this is some great connections to be making for free response questions. Okay, let's move on now. And here's some things that we can do and how we're affected by these. Our immune system, of course, helps us to fight off diseases, helps us to fight off things when we're sick. And if our immune system is compromised, of course, that becomes a compromise, and the HIV is a great example of that. The nervous system is affecting your brain, maybe affecting how you walk. These are pretty important things. And the endocrine system, basically your hormones. And this is going to talk about, when you should grow, how your brain should develop, how you should develop through adolescence, how you should develop sexually. So these are hormones that are just really affecting the person that you become or are becoming. And if that's disrupted, of course, that becomes a problem as well. So things that are going to challenge these hormones here are HAAs. Gender benders, again, will change sexual traits, and the thyroid disruptors can affect how your, these are things that can affect your thyroid, and toxic chemicals, of course, fall into the phthalates, are kind of plastic that gets into your system and causes damage to all these things, and cancer as well. So these are nasty objects that we developed for the betterment of human beings probably, and didn't realize the side effects. Okay, so here is one that is a birth defect and also will cause brain damage, and that's mercury. And you've probably heard the phrase mad as a hatter. And the idea there is that mercury was largely used in the hatting industry. So these people who worked in that industry lost their minds and became a little bit crazy, and Alice in Wonderland made that famous. So human activities amount for 2/3 of it. Also comes from volcanoes. There's mercury that's going to be in the air anyway, or in the ecosystem, I should say. And once it gets in there, it's a great example of biomagnification with not so great results. All right, so one of the things that we can do here, or the way we can get mercury into our system, is through the fish, as it biomagnifies through the food chain. And if we're involved in that food chain, and that's because when the mercury gets in the water, and then it turns into methylmercury, it can be taken up by the lowest levels of the food chain in the water. And that becomes a real problem, and is how a lot of mercury problems have happened. Who's most at risk? As always, it's going to be folks with compromised immune systems. So if you have a disease that has compromised your immune system already, you're going to be at risk for all of these things. And also children who don't have the same immune systems yet. They haven't been developed. They're more likely to be less sanitary. If you've been around some little kids, you know what I'm talking about. And old people as well, because their immune system is not what it was in their prime. Okay, this is another good place for you to pause and take a good look at how the mercury gets into the food chain. And here you can see at the bottom it's detailed where the organic mercury, that's the methyl mercury, the CH3HG, and that's where it becomes the methyl mercury and gets into the phytoplankton. I've seen it where they give you extra points for knowing about the methyl mercury. But being able to describe the idea of industrial processes, putting mercury into the air, burning coal can do that, putting it into the air, the winds, and then the precipitation, get it into the ground and into the water. And so I'll take a couple seconds here while you can pause and look at this. All right, we'll move on. Okay, so here's another good place to pause. I guess another thing to talk about with the mercury is batteries. So there's mercury in batteries, and that's why it's important to properly dispose of batteries rather than to just throw them in a landfill where they might leach out into the ecosystem. The landfill is not made to keep the mercury out. Okay. All right, this is just an idea of these HAAs and how they affect the hormones. On the left is the normal hormone process. So, the hormone attacks to the cell and does what it needs to do. In the middle, there's a mimic. So now there's something that mimics it. It can attach to the receptor, and then it's going to block the hormone that's supposed to be doing what it's doing. So maybe here it's going to give female characteristics where they're not called for, maybe even in a male, and that becomes a problem. A hormone blocker just does that. It won't let the hormone do anything that it's supposed to be doing because it can't even get to the cell in the first place. The same thing with the mimic, except it now does some, it also gives a result that you don't want. So that's the idea there. All right, bisphenol A, they call them BPAs. These are estrogen mimics, so it's good to know about this. Mostly they're found in water bottles where we're aware of them. They're a plastic. And so we know there's been a big outcry about the bisphenol A that's in water bottles, the regular water bottles that you drink. And the idea is that if you use them long enough, this will get into your system. And also if you put these water bottles in sunlight, that can be a problem too. Okay, so how much at risk are we at here? What are we talking about? So that's what toxicology is. It's the study of how toxic things are to you. And this is not a perfected science because there's so many things that are going on with it, but we're certainly learning more all the time. One thing about the amount of damage that it'll do is what is your dose? Also, how old are you? As I've mentioned before, genetic makeup is another thing. Some people seem to have good genes, and they can do all kinds of things that would really, really damage other people. There's always stories of guys 110 years old, or a woman's 110 years old, and they smoke cigars all day long, and they drink whiskey. And I couldn't do any of that stuff. So there we go. Also, you have to take into account that there's so many different things that are happening here. So if you're doing a combination of things, they're going to have a different effect. So that's hard to figure out as well. Cigarettes are always one that you don't want to throw into the mix because they always make everything worse. Not so good on their own either. All right, and how much they're going to stay fat soluble and how much they stick around and what the biomagnification is. So that has something to do with the toxicity. Okay, so acute effect is an immediate effect, and a chronic effect is one that happens over time. So a shark attack would be an acute effect. That would be quick. Chronic effect, cigarette smoking, is a good example of that one. People maybe aren't as concerned about it as they should because it affects you little by little by little. So these are all the different things that are going to go into figuring out what is right for you or not right for you as far as the amount of exposure that you can have. And there's a lot of variables that go into it. A bigger and bigger one now is this DNA situation and understanding it a lot more. The genetics of the individual is quickly becoming especially with computers that can run many more scenarios than they could before. But this is quickly becoming the way of treating diseases more and more. And I believe really will be in the future. And some great gains will be made in that area, I believe, as we collect more and more information. All right, so the umbilical cord, the idea here is that we're trying to find out what things are already in newborns. So what is the background now of what we're starting with here? And we've already talked about the idea of these things that are affecting infants and children more than adults. Okay, so now we're going to take a look at some of these terms. I have some graphs coming up that'll help me to describe these terms to you. And the idea is with lab animals is, well, it becomes a moral question, right? You know, in one respect, you'd rather do these tests on things that you're not sure of on animals rather than people, so that you're not doing harm to people. And then there are people who will say, well, that's not good for the animals either. We don't like that. That's your world view that's going to come into that. Hopefully the idea with not putting humans in harm's way is that you can do the studies and then extrapolate them to humans. It doesn't always work that way. Maybe there are different ways that we can do it, and we can use more computer models or tissue cultures or maybe these things that aren't alive yet. But these are things that we're constantly experimenting with, so the game is constantly changing. And a big part of it that makes it so difficult is these studies. You know, you have to do them for a very long period of time, and there's so many variables that go over the course of a human's lifetime if you're following a human through their lifetime. So this is a curve that talks about the LD50. The LD50 is the lethal dose 50, and this is considered pretty dangerous. You know, there's going to be different tolerance in different members of your community, and some folks are going to be dying at a smaller dose, and some it'll take a much higher dose to kill them. But the LD50 is the lethal dose, the killing dose, where 50% of your individuals will die. That's considered bad news. All right, this is a good one to pause on too, give you an idea of what the lethal doses are for humans for some things. I always wonder at the bottom there, more than a quart of water for a 70-kilogram person. Okay, but what's the time frame? Because I drink more than a quart of water, but is it in one sitting? I don't know. But very interesting. So maybe pause and take a look at those and see what you might want to avoid. Definitely avoid botulism and nerve gas. Okay, maybe you've had time to pause and we can move on now. This is the idea of threshold and no threshold. On the left you see there's no threshold, and that means that the there's an immediate effect. So there's an immediate effect here, and that means that right from the beginning you're feeling an effect. Maybe it takes a little while with a nonlinear dose for it to really start affecting you. On a linear dose, if you double your amount, you're doubling the effect. Triple the amount, triple the effect. So that's the idea of the linear and nonlinear no threshold threshold setups. And on the right-hand side, you see a threshold, and that means that at the beginning, at a very low doses, it's not a problem for anybody. And then once you hit the threshold, it starts becoming a problem. And the more you have, the bigger the effect is going to be. I guess water. Water is not a problem for anybody in small amounts, right? If it's good water. Okay, so this is the idea of the, talking about epidemiological studies. That's just watching people for a long period of time, and you're not watching a lot of people, and you're really, really wondering about all the different effects. And plus, it takes a long time, like maybe a lifetime, to find out if there's going to be effects or not. So this can hold off on the production of new, maybe helpful things if we don't know what the effects are. Okay, so it's now not an exact science, but a developing science, and it's certainly worth trying to figure it all out here. But our tests are becoming more and more sensitive. Have we always been exposed to these things, but we weren't worried about them until we knew they were there? Do we know what levels are really dangerous? There's just so much that goes into these studies. All right, this is another good one to pause, and great connections that you could be making. I could see this being in free response questions, and just an idea of the different things that are in your house here. So this is the idea of how things get to you, and then good for you to do a little bit of a research to know what the damage these things can do when they get there. We've already talked about phthalates and bisphenol A, and so there you go. But maybe I will give you some time to pause here and take a look at the way your house is trying to get you. All right, don't worry. Forewarned is forearmed. We'll get back to the video here. Hopefully, you had some time to pause and look at those because they're good ones. Good ones to know about, I should say. All right, so what is the thing here? What are the acceptable levels? Like I said again, these are difficult to determine. We don't know so much about them. All right, so with the precautionary principle, the idea is maybe we should just wait and not do anything until we know. But then again, that could take useful products off of the shelves where they could be doing us some good. It's really a difficult question. So we have recognized some things, though, that we all want out of the picture. And POPs are persistent organic pollutants. So the dirty dozen, there are treaties to get rid of them. DDT is one of them, PCBs, that kind of thing. All right. Here's another time where human beings have gotten together. Remember I said chlorinated or fluorinated compounds? Well, that's what you have here, a chlorinated, fluorinated carbon. Chlorofluorocarbon, CFCs. So these were used in refrigeration and in aerosol cans, and they were widely used, and then we found out that they were punching a hole in the ozone layer. And we'll talk later about why we want the ozone layer to be there in our air pollution sections. But this is an individual who found a way to clean circuit boards without CFCs. So some good has been done, and the ozone layer has come back. But also that's part of an agreement that we're not going to do that. The Montreal Protocol. Okay, so risk analysis, again, the biggest thing is poverty, as we've said, and the lifestyle choices that you make. So there's a lot that you can do with your risks, cutting down on your risks. All right, so here are some good things to know here, but indoor air pollution and outdoor air pollution are really high-risk health problems, and something to look out for. So another good screen to pause. You can see on the bottom end, groundwater pollution and oil spills are low risk. Well, that's because they don't happen as often. But when they do, they become very detrimental very quickly. But why don't you pause again, take a quick look at these, and we'll move on. Okay, let's move on. All right, so this is the idea of annual deaths. These numbers are, again, a little bit out of date, but certainly give you a good idea, and you can see that tobacco-related deaths are pretty big too. So avoidable, but that's one that is definitely, the perception of that has changed. And there you go. Okay, so this is a nice little chart that tells you in the United States how much these different things will shorten your lifespan. I thought that's an interesting one. Born male, I lose 7.5 years right there. But I'm not going to lose years for smoking. Well, there you go. Very interesting. I'm sure these numbers are a little bit, it's going to be some kind of average there. All right. So nicotine, yes, terrible stuff here, the nicotine. And such a difference in the way nicotine has been looked at, or cigarettes have been looked at in my lifetime. I've told the story in class probably already, but I'll tell it here, that in my high school there was a senior privilege. There was a smoking section where you could go and smoke. And I do remember you would walk in the bathroom and there'd be just clouds of smoke coming out there from everybody smoking their cigarettes. Thankfully, we don't have that anymore. Now, it smells kind of sweet in there when people are in there doing their vaping, getting their nicotine in a different way. So it's a lot sweeter smelling, but still just as dangerous, of course, maybe more dangerous. The passive smoking, secondhand smoke, well, when I was your age and even a while after that, although it hasn't been in your lifetime, really, probably that you remember, but there was smoking in restaurants. There was smoking on airplanes. And now we're much more aware of, people aren't going to smoke around you because it's dangerous to your health. But very different outlook now. So it costs a lot to smoke. It's very costly, and a large part of that is taxes. Also, they put warnings on there that it's very dangerous for you. So these are the ways we cut down on the smoking. But yeah, it's been a cultural shift there, because when I was your age, it was much more accepted. And not too long before that, they used to have cigarette commercials where doctors would tell you their favorite brand of cigarettes, if you can imagine that. Okay, so you can see that tobacco use is a big cause of death. And here are some of the other ones. Illegal drug use, especially with the opioid crisis right now, is becoming a big issue. So these numbers do change over time. But these are some good things to try to avoid. Okay, so hard to figure out what's going on here. You have your technology, which is not really reliable, and human reliability as well. And when you start taking all these things into account, the room for error is very large. So it's hard to figure out what's going on all the time. People don't always know exactly what's going on. Maybe we're more afraid of some things than we should be. Sharks or sharknadoes. And maybe we're less afraid of some things as we really ought to be, maybe in the case of cigarettes. So we took a look at all these things. Optimism, so well, it'll never happen to me. The unfair distribution of risks is, well, one thing is we don't dispose of toxic chemicals in areas where rich folks live generally. So that seems to be something that's along the lines, even in the United States, on poverty lines. Also true in different parts of the world. We'll send our waste that we don't want to deal with here because we know it's dangerous to other parts of the world, and then they'll deal with it. And that's a big thing with electronic waste these days. From all of our computer devices, our cell phones, smartphones, and all that. Okay, so these are the things that you have to do to figure out how much risk you want to have in your life if you want to be informed about all that's going on. And that's the end of this slideshow. I hope you enjoyed it. I hope it was helpful, and I look forward to seeing you back in class.